Hey everyone! In this video, I wanted to create the classic Hello World application for GPIO. Most programming languages, the first program people write outputs the text Hello World to the display. For GPIO, which is General Purpose Input Output, the equivalent seems to be blinking an LED. To follow along, you're going to need an LED, a 220 ohm or to 1K ohm resistor, a flipper zero, and a computer with internet. Let's get started. If you don't have a breadboard, you can skip ahead to the next section. You'll remember each column is connected together. And an LED has a long wire and a short wire. That short wire is cathode, and we're going to make it on the same line as the black wire. So make sure you have the short wire and then put it in the same row as the black wire. Next, we have the resistor. This is a 220 ohm. You can use any value between 220 and 1K. Doesn't matter which direction the resistor is. We're going to go ahead and connect one of the wires to the same row as the long wire from our LED. And then finally, we'll connect another wire to the other side of the resistor. So we have the black wire going to the short LED, the long LED going to the resistor, and then the other side of the resistor going to this red wire. The color of the wires don't matter, but I think it makes it easier to use red for the positive and black for the negative. So we'll plug that red into the 3.3 volts, and then we'll plug the black into the ground, and you should see the LED turn on when you do that. So now that that's working, we're going to go ahead and plug the red into the A7 pin, pin 2, and then the black into the ground. To make sure we have it wired up correctly, we're going to go into GPIO and then choose manual control and then press the OK button to turn the light on and off. If you don't have a breadboard, instead what you're going to do is take your LED and bend that long pin out. So we're going to take a long pin and extend it sideways. And then for the resistor, we're just going to kind of wrap it around that pin so that the resistor and the long pin from the LED have a good connection. And then we'll go ahead and cut off some of that excess wire. You can use scissors or whatever. So the wire from our LED is going to go into ground. And then the wire coming off of this resistor is going to go into the positive. So the resistor should be in pin 2, A7, and the LED should be in ground. Make sure that this little piece between the resistor and the light doesn't hit either side. You don't want it to hit the other side of the resistor or the other side of the light. My flipper is running the GPIO manual control app, and when I click the OK button, you can see the light turns on. I found some heat shrink tubing, which we can add to our resistor to make sure nothing shorts out. Again, we have the cathode from the LED going into ground and the resistor going into pin 2, which is known as A7. Pressing the OK button on the GPIO manual control still works. So over in the Flipper Zero firmware, we're going to click on code and then click on copy to copy the URL to the repo. If you're not using official firmware, you'll have to use a repo that matches your firmware. In Visual Studio Code, we're going to do Control-Shift-P to bring up that palette. Type in get clone and choose get clone recursive. And then paste the URL that's on our clipboard and then choose clone from URL. And then go ahead and choose any folder you want to put your firmware into. And that'll take a little while to install, but eventually you should get a pop-up. And then go ahead and click on open or open a new window if you already have something open. Then click on yes, I trust the authors. Then right-click on FBT and choose Open in Integrated Terminal. Type /FBT VSCode_dist and press Enter. That command will take a while it downloads the toolchain. And then once it finishes, close Visual Studio Code and reopen it. Once everything's reloaded, go ahead and do Control-Shift-B and then choose Debug Build. That'll take a little while it builds all the firmware. Once it's done, go ahead and right click on applications_user and then choose new folder. We'll name our folder Blink, B-L-I-N-K, press enter. Then we'll open applications, examples, example thermo. Then for application FAM, I'm going to right click and choose copy. And then in Blink, we'll right click and choose paste. We'll do the same thing with the PNG, right click copy, right click in Blink and say paste. And then we'll right click on the PNG and choose rename, and we'll rename it blink_10px.png. Press enter. We'll right click on Blink, choose new file, and then type in blink.c and press enter. And then go ahead and open the application.fam file. We'll rename the app ID to GPIO_blink. Then we'll set the name to GPIO blink. We'll rename the entry point to GPIO_blink_main. Update the FAP icon to blink_10px PNG. And then edit the category to be GPIO. That way our applications with all the other GPIO applications. Next, we'll right click on our PNG file and say Reveal in File Explorer. Then we'll right click on that and say Open With, and I'm going to use paint.net. You can use any image editor you want, and you're basically just going to zoom in because it's just a 10 by 10 pixel image, and then go ahead and just kind of erase what you have with white and then draw what you want with black. I'm just going to draw a picture of an LED, and then I'll save my file as a PNG. All right, let's write some code. We're going to do a pound include of fruy_hal.h. And then we're going to want to make our entry point, which is this GPIO blink main. We're going to want to say unused P. We're not taking that parameter. And we're going to want to return 0. Okay. Let's go ahead, Control-Shift-B, launch app on Flipper. Okay. And our app ran and immediately exited. So at this point, we're ready to add our code. So we're going to do a fruy hal GPIO init simple, and it takes the pin we want to use, which in this case we're going to want to use GPIO ext PA7 because we're in pin A7 right now, so that's why PA7. And we're going to want to use a mode of GPIO mode output push-pull. And push-pull means that it'll push us to 3.3 volts or pull us to ground, 0 volts. So now that that's done, we can do a fruy hal GPIO write. We'll use the GPIO ext. And that second parameter is a Boolean. I'm going to go ahead and just say true. And I'll just add a comment here so we know what it's doing. And then we're going to do a fruy delay milliseconds. Sure, 1000. That's 1 second. And then we're going to want to, yes, correct, turn the light off. We can delay 1 second. And now we want to fruy hal GPIO init simple. And this is incorrect. We want mode analog, and the comment is correct. Okay, so now let's go ahead and look what we've got here. Enable pin A7 for output. Push pull. LED on 1 second, LED off 1 second. Go ahead and save that. And we'll Control Shift B and launch app on Flipper. And you can see the light turns on for 1 second. So now if we want to make it just keep doing this loop until we press the back button, let's go ahead and say do. We'll move this code inside of the do loop. While Frui HAL GPIO read, and then we want to use GPIO button back. Let's see if that works. Control Shift B, launch app on Flipper. And then I'll press the back button and it exited. If your frequency of blinking is faster, you can pound include frui_hal_pwm.h. Next, we comment out the GPIO init call. Next, we'll call frui_hal_pwm_start. And this takes 3 parameters: the channel, the frequency, and the duty. It supports pin A7 and A4. We're using A7, so I'll just hit tab. And then so we can see the light blinking, I'll change it to 10 Hertz instead of 1 kilohertz. And then at the bottom of the program, we'll go ahead and comment out that init simple. And then we will add a frui PWM stop call. And this just takes the channel. So we'll remove those other parameters and disable the channel. And then we'll go back up and comment out the write calls as well. All we actually need in the loop is just a little delay so that the processor is not pegged. And I'll set that delay to 100 milliseconds instead so that it doesn't take as long for the back button to take effect. And then Control Shift B and then launch app on Flipper. There you go. Then we'll press the back button. We'll update our Frui HAL PWM start to use 1 Hertz with a 20% duty cycle. So that means 1 times a second and 20% on, 80% off. And then Control Shift B, launch app on Flipper. And you can see it's blinking once a second, and that's 20% of the time it's on and 80% of the time it's off. I go ahead and press the back button to exit the application. And then I'm going to go into Applications, and then GPIO, and then I'm going to go to GPIO Blink. So there's our application with our icon that we've installed. So hopefully you found this video useful, and we learned 2 different ways to blink an LED. Please like and subscribe, and if you have any questions, please leave them below.